Question 16. A loan of $25,000 is used to purchase a car. The term of the loan is 3 years and the interest rate is 9% per annum, compounded fortnightly. Which equation should be used to calculate the fortnightly payments, M? I'm going to apply the process of deductive reasoning to rule out the incorrect responses in order to find the correct response. Let's go through the question. A loan of $25,000 is used to purchase a car. The term of the loan is 3 years and the interest rate is 9% per annum or per year, compounded fortnightly. So the first thing I need to work out is the interest rate per fortnight. Now 9% in decimal is 0.09, and the reason why I'm converting it into decimal is because in all 4 responses the interest rate is quoted as a decimal, not as a percentage. Now there are 26 fortnights in a year or per annum, so the interest rate per fortnight is given by 0.09 over 26. Now that rules out options A and B, since the interest rates that are used in the formula is 0.09 or 9%, not 9% over 26. So immediately we can put a cross through these 2 options. The next thing we need to work out is the number of compounding periods. So there's 26 compounding periods per annum or per year, and the loan goes over 3 years. So the total number of compounding periods is given by 26 times 3, which equals 78. Now that rules out options A and C, since the index here corresponds to the number of compounding periods. So we can put a cross through option C as well. So that leaves option D as the only viable option left. Therefore, the correct expression is given in option D. Treating this multiple choice question as an extended response or a free response question, we could apply recurrence relations and then geometric series to model the situation and come up with the expression that corresponds to the correct answer, which was option D. Now I'm going to let capital P equal 25,000, and that corresponds to the principal or the amount borrowed, which was $25,000. I'm going to let capital R equal 1 plus 0.09 over 26. Now, capital R represents the percentage increase on the balance owing. So if I want to increase it by 0.09 over 26, which is the fortnightly interest rate, I multiply the balance owing by capital R. I'm going to let capital M equal the fortnightly repayment, and AN is equal to the balance owing after N fortnights. So working out A1, so that represents the balance owing after the first fortnight, we get capital P. I'm going to multiply it by R, which represents a percentage increase of 0.09 over 26. And they're going to take away a fortnightly repayment of capital M. Now A2, which is the balance owing at the end of the second fortnight, is found by taking the balance owing at the end of the first fortnight, multiplying that by capital R, and then taking away M. Substituting PR minus M for A1 and then expanding the brackets, we get A2 is equal to PR squared minus MR minus M. So at this point, we can see a pattern starting to form. And just to make sure we got the pattern right, I'm going to work out A3, which is an expression that represents the amount owing at the end of the third fortnight. So that's equal to A2 multiplied by capital R, take away another fortnightly repayment of capital M, and substituting PR squared minus MR minus M for A2, and then multiplying all that by capital R and then taking away M, expanding the brackets, we get A3 is equal to PR cubed minus capital M outside of 1 plus capital R squared in brackets. From this expression, we can generalize a formula for AN. So AN, which is the balance owing at the end of the nth fortnight, is equal to PR to the power of n minus m outside of 1 plus r squared plus dot 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 plus r to the power of n minus 1. And we get the n minus 1 if we look at the subscript here of 3 and we look at the highest power of r here, 2, it's 1 less, which is why it's n minus 1 there. Note that this is a geometric progression in the brackets, with the first term being 1, the common ratio being capital R, and there are n terms. So we can replace what's in the brackets here with the sum of a geometric progression or a geometric series formula. So we get AN is equal to PR to the power of n minus m outside of r to the power of n minus 1 over r minus 1 in brackets. Now the next thing to note is that the loan is paid in full when AN is equal to 0. In other words, there's no more money outstanding. So substituting 0 for AN here, we get 0 is equal to PR to the power of n minus m outside of Rn, or r to the power of n minus 1 over r minus 1 in brackets. And the final step is to make P the subject. So I'm going to do that first by moving PR to the power of n over to the other side. So we get PR to the power of n equals m outside of r to the power of n minus 1 over r minus 1 in brackets. And dividing both sides by r to the power of n, we get P is equal to m outside of r to the power of n minus 1 over r minus 1 in brackets times r to the power of n. If we substitute the values for P, M and R, we get 25,000 is equal to m outside of 1 plus 0.09 over 26 in brackets to the power of n minus 1, so that's in the numerator, all over 0.09 over 26 outside of 1 plus 0.09 over 26 in brackets to the power of n, which is in the denominator. Hence, the correct answer is option D.